All right, so we're supposed to A, write the derivative formula, and then B, locate any relative extreme points and identify the extreme as a max or a min. All right, well, let's write the derivative first. So f prime of x is equal to, well, we'll bring that down as 2x plus 2.5. All right, so that's pretty easy. Now, we're going to set that equal to 0 to find kind of our c. So we're going to subtract our 2.5, and we'll get 2x equals a negative 2.5, divide by 2, and so x is equal to a negative 1.25. So remember, when we're doing these, we want to kind of find our c f of c, and this comes from the derivative, and then we plug it back into the original function. Okay, so now we're going to take negative 1.25, plug it into f of x, so we're going to have f of negative 1.25, and so that's going to be a negative 1.25 squared plus 2.5 times negative 1.25 minus 6. And if we plug this into our calculator, we get, and I'm just going to do it on my hand one here. So it looks like we get a negative 7.5625. We'll just keep it to that number of decimal places. Okay. And so what we now have is our relative what? All right. So we have looks like probably a min. So when we have this, it's going to give us opening up, and so that has to be a relative min, and it's going to be at negative 1.25 and negative 7.5625. Okay, so probably could round that to negative 7.56 and we'd be good, but I just went ahead and took it out to that 4 decimal places. And so when we have the positive one here, it's going to be opening up, and so that has to be that relative min. Okay, if we had a negative out front here, that would give us, like if you're launching a rocket, that's usually the negative one, and so that would give us the relative max, but we have the relative min. All right, now what about this one? We have the derivative is h prime of x equals, and now we have 3x squared minus 16x and then minus 6. Okay. Well, I can't factor that one, or I can't solve it simply, so I'm going to use x equals, it's going to be a minus b, so it's going to be a 16 plus or minus square root of negative 16 squared minus 4 times 3 times negative 6 all over, and we have 2 times 3. Okay. And so we're going to get two values, which we expect because we have a squared term. Okay. And so if we plug all that in, we'll have 16, and then I'll do the plus first, the square root of 16, negative 16 squared, and then minus 4 times 3 times negative 6, and then divide that by 6. And so I get 5.6851 for the positive, and x equals, now if I do the negative, I get negative 2 divided by 6, negative 0.3518. Okay, so that's two values, so two critical points. And we would expect that because a cube is going to have, it's going to be some kind of a thing like this. So you have 1, 2, or, it could come down and do something like that, kind of depending on what your function is. Okay. And so let's see here. Let me plug those values in here, and we have 8. All right, so we get for this one, f of x equals, or f of 1 point, or the 5.6. Let's put that all in there so we have everything. f of 5.6851 equals negative 108.929, and f of negative 0.3518. Change that. Okay, and that says it's 1.077. All right, so now how is our graph going to look? So it's a positive, it's x cubed. So it's going to look like this one. It's not going to look like that one. It's going to look like this one. And so this one would be the most left one, which is that. And so that's going to give us a relative max. This one's to the right, so it's going to give us a relative min. Okay, and if we wanted to write our points out, that would give us 5.6851 comma negative 108.929, and then we have the negative 0.3518 comma 1.077, and that was the min and that was the max. Okay, all right. And you could always, if you needed to, plot this and see what it looked like on your calculator. But with general things, we know if that's positive and then say x squared, it's going to be opening up. And with this one, you should have your opposite going opposite ways like this, and so it should look something like that. Now with the going up and down, this one's going to go way down, and that one's just going to go up a little bit above the axis. But that's kind of how it's going to look. All right. All right, one more. F of x is equal to that. So our derivative is going to be 12 times ln of 1.5 times 1.5 to the x, then plus 12 times ln of 0.5 times 0.5 to the x. And remember, if we have, b to the x, then what we have to do to get the derivatives, take ln of b times b to the x. Okay, and so that's why we have both of those like that, and then our 12 is just a constant multiplied by them. All right, so now what we need to do is we need to solve this as equal to 0, okay? And so 0 is equal to that whole thing, and so that's not going to be easy. And so what I'm going to do is I'm just going to plug that into my calculator, and what we can do is we can plot this and get a point for our where it crosses the axis there. So we can do 12 ln 1.5 end, and then times 1.5 to the x, and then we had plus 12 ln of 0.5 times 0.5 to the x, arrow down, and I don't know if I have the right graphing. All right, so it's doing something there. So how is that going to work? Let's go out maybe minus 50 to 50, and we can go by tens, and we can go minus, I don't know, 50 to 50 by tens to make sure we have more of our graph. So yeah, so it's just going to be, going like that. So what we need to do is find where it crosses. So we go on second trace, and we want the 0. And so left bound, that's in the negative, so that works. Now the right bound, we need to be positive, so that works. And it looks like 0.4881 is going to be our x. Okay, is equal to f prime of x, and so x equals 0.4881, and that was from the calculator. So we didn't try to solve any of this by hand. We just said where does it cross that x-axis, and that's where it was. So now we need f of 0.4881, and so now we're going to plug that into here and here, and so we'll have 12 times 1.5 to the 0.4881, and then plus 12 times 0.5 to the 0.4881, and if we plug that into our calculator, that gives us And that gives us 23.1818. Okay, so that's going to give us the point 0.4881 comma 23.1818. Now, do we know what this graph looks like? Well, you know, off the top of my head, I don't. So I'm going to say, well, let's go and check. But, we can easily do that by plugging it into here. So we can clear out part of this. We can delete this. And then we can come over here. Oops. Delete that. And now we have our original. So what does it look like? Looks like a parabola type item. And so it's going to be our minimum. So that's going to be kind of one of those keys. If you can't determine what the shape of the graph is, you can always plot it and then see. Oops. And so that's going to be our relative minimum. Okay. All right. So let's pause there and we'll come back for two more.